This is part of Westport theory, but Westport completely I'll send a presentation to you. This is ammonia and water molecule. Ammonia, water. In Westport theory, we come across 5 examples. 2 of them are beryllium chloride and boron trifluoride. Then we have water molecule, ammonia and methane, CH4. So those 3 molecules of Westport which are required, I will just draw those structures here. In Westport theory, the concept is like electrons are not single particles. They are not particles, rather they behave as charged clouds. That's because it's too small. Now the atom is very, very small. Inside the atom there are electrons. These electrons continue to move at very high speed, and they're very small, and also they move at a very high speed. The distance where they move is also very small. The place of movement, their distance where they move, their own size and their speed. When we see all these 3, it is impossible to say where is the electron at any particular point of time. The time and place of an electron cannot be said at any time. Like if you take even a small particle, what do we know? Say a small bead. I have a bead here. This is a bead. This is small compared to our size, it's small. But at this moment it is here, I can say this. Even if I throw it, it's not impossible to follow its path. Nanosecond. Now you might have seen stopwatch. Seconds. It shows something besides seconds which goes very fast. That is microseconds. There are smaller units of time, nanoseconds, etc. Now, when particles are very, very small and they move at the speed of light very fast, it is almost impossible to say at what time where they are. It doesn't mean we can't point out that location. Exact position, it is difficult. Because by the time you go to that position, that is you point that particle would have gone from there. Because it is so small and it moves so fast. So it is accepted that instead of taking electron as a particle and trying to figure out where it is and finding the bond, rather which path electron moves, that path is considered as a charged cloud. Now if electron is this much small and it vibrates fast, very fast, it goes here and here. Instead of saying electron is here or here or here, instead of that we can take this area as a charged region. Region or area where the electron power is present. So this electron's charged area is known as a charged cloud. Electron is considered as a charged cloud rather than a single particle. That is the basic concept of Westport theory. So even if you consider it like that, electron is a particle only. Electron is a particle, it can be counted. So when these charged particles, they undergo bonding. If they are bound to another atom's electron, it is called a bond pair. One electron from one atom, another electron from one other atom, if they are coming close together, that is called as a bond pair. If 2 electrons of the same atom, they are not bound to anything. They did not take part in the reaction. They stay as it is. Like electrons in 1s, they are like this in beryllium. Beryllium chloride, when it forms, 2s bonds, but 1s 2 electrons remains as it is. Like this, if electrons are left in the atom, they are known as lone pairs. Now lone pairs and bond pairs of the outermost shell. Lone pairs will be there in every molecule because inner atoms do not take place in bondings. But it does not affect it. The outer shell's lone pair, outer shell which bonds bond pair, that can be used to predict the shape of the atom. Take example of NH3, ammonia. The nitrogen 7, 1s2, 2s2, 2p3, 1s2, 2s2, 2p3. So 1s2, 2s2 and 3 electrons here, 2p3. Since it has 3 single unpaired electrons, each one will bind with 1 hydrogen each. There is no doubt here, so no hybridization is not required. It is direct bonding between nitrogen and 3 hydrogens. So then that happens. When the 3 hydrogens bind themselves, nitrogen at the center is bound to three hydrogens. But nitrogen, if you observe, 1s2, 2s2 and then 2p3. So these 3 electrons came here. These 3 dots are these 3. What about these 2 electrons? It belongs to 2s shell. It's not in the inner shell, it is in the same shell. Both belong to the second shell only. In the second shell, these 2 electrons are here. They are in the outermost shell. So we should put their dots here. This also comes here. These 3 of the P. And this bonding is like this. So the shape should have been this. The shape should have been planar. But it is not so. It's not so because this lone pair and this is a bond pair. The electron from hydrogen and the electron from nitrogen, they both form a bond. This is called a bond pair and this is called a lone pair. So these 2 are bond pairs. These 2 are bond pairs. This is a bond pair and this is a lone pair. Now Westport says that these are like negatively charged particles forming a negative charge cloud. These are also negative charge cloud. This is also a negatively charged cloud. But this is a cloud of bond pair and bond pair. So bond pair repulsion. It will repel. Both are negative charges, so they will repel. Bond pair repulsion is less than bond pair, lone pair repulsion. This bond pair, this lone pair, the repulsion between them is greater than the repulsion between these 2. Which is less than lone pair repulsion. Suppose there are 2 lone pairs, they both will have maximum repulsion. So in this we have only 1 lone pair and 3 bond pairs. So this molecule, instead of being in this shape, the nitrogen comes here with the lone pair and the 3 bond pairs of hydrogen, this 2 bend downward. Actually all the 3 bends. It looks kind of a tripod. You know what is a tripod? So like a tripod, camera's tripod you must have seen. So imagine that there is a tripod of that. The 3 legs are these 3 bonds. Below, at the bottom of those 3 legs, we have 3 hydrogen. At the top, above where you will place your camera, there this nitrogen sits and above that is the lone pair. So this shape itself, instead of being a plain shape like this, it occupies kind of a trigonal pyramid. Hence its shape is trigonal pyramidal shape. Okay, it's not plain. It's not a plain figure. It goes to this figure. Okay. So now this is ammonia's shape. Ammonia NH3. The shape of ammonia NH3. It is like this because of two P. That is these 3 from 2p and from hydrogen, single hydrogens, HH only comes. Okay. So here this hybridization of ammonia, here we call it hybridization because this lone pair bond pair shifting takes place. Okay. It leads to trigonal pyramidal molecular shape. Now the angle should have been, if it is like this, it should have been 90 degrees each. Between this, 4 are there. Between them the angle should have been 90. But instead of 90, the angle here between this lone pair bond pair changes to 107 degrees. 28 minutes. I think textbook it will be clearer. 107 degree, 28 minutes. The angle shifts. Instead of being 90, it goes to 107 degree, and here it is 109 degrees. This lone pair bond pair is 109. Between them it is 107. Two different angles are there, but what is given in 10th class textbook, and see that and follow that. Okay, let's continue with water molecule. Because it is of the same concept. Water is H2O. Oxygen 8, 1s2, 2s2, 2p4. 1s2, 2s2 and 2p4. So these two can bind with 2 hydrogens. That's what happens. So oxygen, these are the 2 lone pairs. These 2 single electrons are here. This is from 2s, this is from 2p. These are the 2 electrons here. Both of them bind with hydrogen. So the shape should have been like this. Shape should have been like this. Linear molecule, straight line molecule. But this is a lone pair and this is a lone pair. Lone pair, bond pair, lone pair, bond pair. The structure is not according to Westport. Lone pair repulsion is highest. So it rearranges and it goes like this. Both the lone pairs occupy diametrically opposite to each other. They take 180 degree, they take sides 180 degree angle between them, and both bond pairs get bent like this. So it is a bent V shape. Water molecule shape is a bent V shape. The angle is about 104 degrees. So this is water molecule. Here what happens is the lone pair repulsion is the highest. So they go directly opposite to each other. Lone pair bond pair repulsion is the lowest, is lower. Bond pair repulsion is the lowest. So these two will be the closest to each other. Then these two, and this will be diametrically opposite. Hence bent V shape. So this is how water molecule forms. The other one is CH4, methane, carbon tetrahydride. CH4, methane. C, 4 sides hydrogen. So the shape should be like this, but because of the hybridization, methane should have been like this. Methane should look like this. But what happens? 1s2, 2s2, 2p2. Carbons. Carbon is 6. So 1s2, 2s2, 2p2. This way 4 bonds cannot form. So this jumped here and created 4 single electrons. S and all the 3 p's are occupied, hence it is sp3 hybridization. sp3 hybridization of CH4 methane. So now when 4 are there, each one can bind with 1 hydrogen. All of them get bound to 1 hydrogen, and because of this hybridization, its shape is also tetrahedral. Tetrahedral means tripod stand of ammonia, you remember? C, H here, H here, H here, and in ammonia there was a lone pair here. Here there is one more bond pair. So it's the same tripod stand thing, but at the top, instead of having a lone pair, we have one more hydrogen. So this is CH4's shape, tetrahedral shape.